Hi there, thanks very much for having me. I'm sorry this is being delivered kind of remotely, but hopefully you can hear me okay and everything's going okay. So today I want to talk about the embodied GIS using mixed reality in the landscape. The way this kind of talk is going to be structured, I'm just going to give a very brief introduction to what I kind of mean by all of that. Mixed reality and everything. Then I'm going to talk about something called location-based augmented reality. So augmented reality is a type of mixed reality. We'll get into that a bit later. Then I'm going to talk about marker-based augmented reality. And then finally I'm going to start talking about something which I've dubbed the Embodied GIS, which is a combination of GIS, Geographic Information Systems, and augmented reality or mixed reality. Finally, I'm just going to talk very, very briefly about where we might go with this type of technology in the future. Apologies if this is a little bit technology heavy, but hopefully we'll be able to kind of work our way through it all, and I'll be available for questions at the end, obviously. Okay, so I started my kind of career as a sort of general archaeologist, but somehow I managed to get kind of moved into the sort of digital archaeology sphere. So I do a lot of work with computers, databases, geographic information systems, websites, kind of remote sensing, you know, all of this kind of computer-based data. But what I really love is landscapes, and I really like analysing landscapes, trying to figure out why people were living in a particular landscape, what they were doing in that landscape, how that landscape affected how they lived, and how they formed that landscape, how the landscape formed them, and all of that type of thing. And the study of landscape really is quite unique in that it comes with its own set of challenges. For instance, generally, if you're looking at a landscape, you're looking at quite a large area. There's lots of things going on, usually, within this particular landscape, and that also quite often brings large data with it. So if we're trying to create a computer model of a landscape, a digital elevation model or something, generally that will be quite a big file, right? And then suddenly if you start putting in all of the different types of things which are in that landscape, like the settlements or the rivers or the different resources that are available, or the ritual monuments or what have you, start putting all of this together, you end up with quite a lot of data which you have to crunch, which is fine. We've got big computers, we can crunch that stuff, but it also brings up quite a lot of questions as well, because you've got a lot of different variables to deal with. And quite often in landscape analysis you don't actually get to dig, so a lot of the sort of fun of archaeology is the digging, but equally if you're dealing with landscapes, then a lot of the fun of archaeology is surveying, for instance. I don't want to teach anyone how to suck eggs, but just to run through very quickly the sort of different ways that we might get information about a landscape. So landscape survey, field walking, I'm sure everyone here knows what that is. Basically, you just put everyone in a line, walk along in a field, collecting artifacts from the topsoil. And then you plot where all of those artifacts are, and usually nowadays you would then put that into a computer and run some kind of statistical analysis which would kind of indicate areas where you might be able to find settlements or houses, or there might be some, the concentrations of artifacts might indicate some buried archaeology. You can do topographic survey. So in the old days we used to go out with a pen and paper and start doing hashard surveys. Generally now that's done a bit more high tech with GPS rover kits and all of that type of thing. But essentially what you're doing is recording the topography of the landscape, the lumps and bumps, and where everything sits within that landscape. And that usually results in a digital elevation model, which is a computer representation of the particular landscape that you're interested in. That can of course now be done completely remotely by using technologies such as LiDAR or what have you, and those technologies lead to even bigger data. And then there's also slightly, I'm afraid I'm mentioning the P word here, phenomenological analysis. So this really is actually just going out, having a walk around the landscape, kind of feeling how that landscape affects your body and how your experience of that landscape is affected by your embodiment within it. So, for instance, if I'm in a hilly landscape and I go down a hill and then come back up to a rise and then see an archaeological monument as I come up the rise, how does that kind of reveal affect my experience of that landscape, or those type of things. In the old days, which we'll talk about in a little bit, phenomenology was generally a little less structured than it is now. But now, actually, I mean, that's me doing some phenomenology on Bodmin Moor. I'm taking audio notes, I've got a camera on my head, I'm actually walking around, stopping every 5 minutes in the landscape, recording what I can see and how that's making me, or how that's affecting my experience. Okay, so we've got all of these kind of field-based landscape surveys. And then with that data, you can start doing computer-based analysis. Some computer-based analysis would be, you know, put it all into a geographic information system, collate it all into a GIS, and then start running some spatial statistics on it. So you might do something like viewshed analysis. This particular little picture here is a viewshed analysis of a place called Peel Gap on Hadrian's Wall, which is a little turret that sits at the bottom of a a little valley in the wall. So we did some, or you could do viewshed analysis there to figure out how far that turret might be able to see and why it might have been placed in that particular location. In this instance, it looks like that turret was placed there because the two turrets on either side couldn't visually survey that particular gap, so they put a turret in there. And then you could do resource mapping, so you would put everything into your GIS and then you could work out how far it is from a particular settlement to a particular resource, or you know, where's the nearest river, and all of that type of kind of landscape spatial analysis as well, which happens quite a lot at the moment. And then you might also be able to do agent-based modelling, which is happening quite a lot as well. As computers get faster and faster and faster, we can do more processes, so you could do some agent-based modelling. Won't go into it very much, but this little screenshot here is a screenshot of a site called Chersonesos, which is a Greek and Roman city in Ukraine, which I worked on for a few years. And I was using modern visitor data here to see where visitors moved around the site, and then I created an agent-based model to predict what would happen if we added, say, 100 more visitors a day, where they were likely to go and how that might affect the conservation and management of that particular site. So there's lots and lots and lots of different things that you can do, computer-based landscape analysis. Well, what really got me going here was, as I was doing all of this computer-based stuff, I was thinking, I feel a bit disconnected here from the landscape. And, you know, there's a computer screen, I'm sitting in a warm office, and really what I want to do is be getting out there and really doing, you know, the work on site. I'm an archaeologist after all, right? So I've going to show you a couple of videos which kind of was my sort of realization moment of what was going on here and where I felt there was a bit of a problem. Apologies to people who might have seen these videos before. I have shown them in a previous talk at TAG, I think, but I think they're quite a good example of really, you know, where this kind of dichotomy between phenomenological or landscape-based analysis and computer-based analysis of the landscape sits. So the first video is, I have a camera attached to my head. I've basically got my iPhone strapped to my head with a headband, and I'm walking along from Bird Oswald Roman Fort up on Hadrian's Wall, and I'm just taking a short walk along Hadrian's Wall. Okay, so it's not a particularly sunny day, but it was actually quite mild on that day. If you listen, you can You hear a bit of wind, but not no bird song, but there was definitely birds singing and all of that type of thing, and the grass was slightly wet, and it was a very gentle kind of lovely walk along Hadrian's Wall there. Now this next video is very, very different. So this is me taking part in the, I think it was 2011 International Stilton Rolling Competition in the town of Stilton in Lincolnshire. Yeah. So basically 2 teams of 4, and you roll a Stilton from one end of Stilton High Street to the other. Stilton's a type of cheese. You roll a Stilton from one end of Stilton High Street to the other. Whoever gets to the end first wins. We were the hula hunks, and we were racing against the Stilton sombreros. So again, I've got a camera attached to my head here. Oh, incidentally, it was compared by the guy who played Willow.
Well, the Stilton sombreros looking very strong. That's an amazing roll.
Yeah.
That's an amazing start.
So I had a bit of a fall there. So the Stilton sombreros have already finished at this point. But anyway, as you can see, it's a very different experience. Quite frankly, hula hunks are an embarrassment. We were rubbish. But my point here is that this is a very different experience. You know, there's people there, that we're rolling a Stilton and with some friends. There's the guy from Willow randomly kind of talking. We're in a town. You know, it's a very, very different experience from the walk along Hadrian's Wall. There's 2 very important similarities between those 2 experiences, between those 2 journeys through landscapes. First of all, I travelled exactly the same distance, so 50 metres. The walk along Bird Oswald was 50 metres, and then that run along the Stilton was also 50 metres. Now, the other similarity is how those 2 very different journeys in very different places would be represented within a GIS. So, if we look at that, that little red line is the 50-metre line which I took. So on the left-hand side there's a 50-metre, the little red line is me walking along Hadrian's Wall, and then the one on the right-hand side is me rolling a Stilton through the town of Stilton. If I was just looking at those on a GIS, I would have no idea whatsoever about that actual embodied experience that happened in those places on that red line. And this is really where I came to and suddenly decided that actually something needs to change here. The GIS is simply too far disconnected from what's going on the landscape. So I decided to start looking into something called mixed reality, a way to bring the computer into the landscape. Just a quick roll back here to talk very, very, very briefly about phenomenology. So phenomenology, I'm sure most people know, is a way for archaeologists to study the life and experience of ancient people whilst embodied in the particular landscape. The sort of greatest proponent of this was Chris Tilley and some other people, and really it involved, at least in Chris's interpretation of it, involved going out in the landscape, writing about what he could see and recording what he could feel and how the landscape kind of affected him from an embodied perspective, and then perhaps moving that experience back to say something interesting about prehistoric lives. It got quite a lot of criticism, mainly because it was a little bit sort of unmethodological, and you know, they never used to particularly write down what they did or anything. So people like Sue Hamilton and Ruth Whitehouse took that all on board and sort of moved it a little bit further forward in terms of methodology and formalised phenomenology a little bit. And their work on the Tavolieri Plain in Italy involved actual, you know, recording sheets where they would go for an hour's walk out from each site, stop every 5 minutes, record what they could see, record how the views were changing and all of that type of thing, and then write narratives as they go along. So trying to kind of formalise the methodology a little bit rather than just making it, oh, I had a nice walk in the landscape. But the point of phenomenology is is really that it's very difficult to understand what it was like to live in a place without actually experiencing that place yourself from your own body. So there's certain things that humans would likely to have shared throughout the whole of antiquity. For instance, if I'm on a windy hill and I'm getting a bit cold, then I might hide behind a rock to get out of the wind. That's just a thing which I, as a human, would do, and we can sort of assume that that might be the same case for people in the Bronze Age, for instance. So we're kind of using our bodies as proxies for Bronze Age bodies, which obviously, you know, there's a lot of problems with, but the kind of main thrust of the whole thing is that you can't know a place unless you've been in a place and experienced a place. And that was really what I felt as well from going through, you know, coming from the GIS side and then realizing how disconnected I was from a landscape. So how do we reconcile this then, the lab-based computer approach to the landscape with the field-based phenomenological approach? So I decided to use something called mixed reality, which is a way of combining the real world with the virtual world. Okay, this is called the mixed reality continuum. On the left-hand side here we have the real environment, the real world. Everything is real, you know, where there's nothing augmented or anything like that. Basically it means the real world. And then on the other side, the other end of the continuum, you have the virtual environment. So that is everything which is created in a computer. Let's imagine that as virtual reality, kind of old school virtual reality. You put on the helmet, you put on the gloves, you know, you sit in a chair, everything is created for you and curated for you by a computer. Okay, so those are the two ends of the spectrum. Now when those two ends combine, it becomes something called mixed reality. So a little bit of one end, a little bit of the other end, somewhere in the middle, you start getting this sort of varying degrees of mixed reality. Okay. So a lot of real environment and a little bit of virtual environment gives you augmented reality. So we're adding small amounts of the virtual environment into the real world. An example of that would be, for instance, an audio tour. So let's say we're going around a archaeological site and you've got one of those audio tours on, and as you get closer to a particular part of the site, the GPS in the audio tour realizes where you are and starts playing a kind of context-specific piece of narrative. So the narrator is being augmented into your real environment, basically via your ears. Okay. On the other end, you have something called augmented virtuality, which is more virtual environment than real environment. An example of that might be you're playing a computer game, and in the computer game the telephone rings, so you move your computer character over to the telephone, your computer character picks up the telephone, then on the end of the telephone you're having a conversation with a real person. Okay, so basically kind of augmenting a real person into the virtual environment. So your computer character might be having a conversation with a real person on the end of the phone. Okay, so that's augmented virtuality, but we won't really deal with that much today. But essentially, real reality plus virtual reality equals augmented reality. Okay, let's go with this. So, augmented reality, this is what we're going to talk about. And how do we access it? Okay, there's a number of different ways to access it. The main way that's used at the moment is either via head-mounted displays or head-worn displays with headphones. So here's some examples of that. These type of things. For some reason, and I don't really know why, augmented reality displays are always on attractive women in fancy places. Right, this is what always happens. Anything which is shown, I guess it's a new technology, I guess that's what people like to see. But in reality it's a little bit more like this at the moment. Kind of, you know, white German computer scientists with circuit boards on their head. This is basically really where we are at the moment with the head-mounted displays. I mean, they're a little bit more sophisticated, but that's basically it. all still in prep, but actually, they're doing quite well at the moment. And basically, you have a head-mounted display which is feeding virtual elements into your eyes and overlaying them on your normal vision. Think of something like Google Glass. Google Glass is a good example of augmented reality. And then you can also access it via handheld devices such as an iPad or a tablet computer. So you can have the virtual elements being overlaid on the video feed of your iPad. Here is an example of one of those applications. So this is an iPhone or iPad application to recreate the moon landing in your back garden.
You're go for landing, over.
Okay, so this is live basically, and what it's doing is it's using the GPS of the phone and the compass of the phone to align the virtual content. Okay, so the phone knows where it is because of the GPS, it knows which way it's pointing because of the compass, and then it's overlaying this 3D content directly onto the video feed of the phone to make it look like Neil Armstrong's hopping out of his little moon lander and jumping around your garden. Obviously it helps if you do this in the snow because it makes it look a bit more like the moon landing, but you see how the phone is panning around and following these people, so because of the compass it's able to keep itself kind of located. It's a little bit jerky, but it's quite a cool app actually. So you can download that moonwalking app, it's called, if you want to after the show. So location-based AR then, that works by using the GPS to situate the user. So most smartphones now have GPS. Boom, thanks very much. It then uses the compass, the digital compass, to figure out which way it's looking. So it knows where it is, it knows which way it's looking. And then it will overlay virtual data onto the video screen, theoretically with the correct perspective. So here's a little app which I made up on Hadrian's Wall, looking at some of the mile castles along Hadrian's Wall. So this is a live screenshot from my phone. That's the video feed of my phone. It's beautiful up there. And then you see the grey dot in the middle. That is mile castle 39. And if I clicked on that grey dot, I would get more information about that particular mile castle. But you can, and up on the top right, there's a little radar screen which shows where all the different next information points are. So they're all the next mile castles along the wall. However, you can see a problem here probably. Those yellow dots and that other grey dot on the left-hand side of the screen there, those are the next mile castles, and that bottom yellow dot should actually be basically directly in line with where the wall goes down into that dip. So it's not working very well, mainly because the compass is pretty shoddy in that particular iPhone. This is an iPhone 3 or something. Things have got better, but it shows you, how it relies on the kind of sensors of your phones to actually work properly. Now, you don't just have to do visual things, you can also use augmented reality to trigger sound events when you're in a specific location. So back on Hadrian's Wall again, for those of you who know Hadrian's Wall, this is a famous place called Sycamore Gap, which is a gap in the wall with a big sycamore tree growing in it, but it's also been made famous because of Robin Hood, Prince of Thieves. It features heavily in Robin Hood, Prince of Thieves. So, for instance, let's say you're walking along Hadrian's Wall, and then when you saw that, you could have it, if you really wanted to, play Everything I Do It For You. So now when I walk along Hadrian's Wall, I get to Sycamore Gap, my phone plays Bryan Adams, which, it's not particularly archaeological, but it's kind of fun. But basically, it's a good example of something which is being triggered by my GPS location and then being augmented into my reality. As I've shown, location-based AR really relies on the accuracy of the GPS and your compass. So it's not wholly accurate, especially when using smartphones. And then it also has things called occlusion problems, which is something which will come up quite a lot. Essentially what's happening is it's overlaying a data layer directly onto your video feed, but it doesn't know what's in the video feed. So the virtual elements are just being overlaid slap bang straight on top, and they're not taking any account of what's actually in the video feed. So for instance, in the Mile Castle example up the top there, that yellow dot should be kind of over along the wall and then down that dip, and it should be hidden behind the dip, but it won't be, because my phone doesn't know the actual form of the landscape. It doesn't know what's on the video screen. It just knows it needs to display things on a particular perspective on that video screen. We'll talk about it in a little bit more detail in a minute. The other way you can get the other way you can experience augmented reality is via marker-based augmented reality. So instead of using your GPS and compass, it can use a particular marker. So that could be, in this case, that's showing on the top right here, it's called a fiducial marker. It's a special thing that your phone can recognize, or a QR code, or it could be a magazine cover. When your phone sees that particular thing, what it will do will replace that marker in your video feed with a 3D object, a virtual object. So it uses computer vision to recognize elements in the real world. The early forms used a specific marker, but now the algorithms have got so much better they can basically use anything. So you can augment something onto the Mona Lisa, for instance, if you really wanted to. This is a completely weird example. Basically, these guys are wearing a t-shirt with a fiducial marker on. You can see that kind of black and white thing there. And what happens is when you look at your t-shirt through a webcam, it automatically puts a rock, paper, scissors 3D hand on it, so you can play rock, paper, scissors with your t-shirt. Completely weird, I know, but it's just an example of how 3D things can be put onto markers. Okay? This next example is slightly more sophisticated, I suppose. I'm not really sure. Basically, on this person's table, they have a copy of the Beatles Abbey Road CD, and then when they hover their phone over it, it recognises the Beatles Abbey Road CD and places a 3D model on top. And in this case, it's placing a whole music player on top of the CD. You'll notice some good occlusion here. In a minute, the guy's going to try and move the CD album, and his hand disappears beneath the 3D content. See there? So as he moves the album, it moves the content, but his hand has disappeared beneath the 3D content, which makes it suddenly look really, really weird. It's been occluded by this virtual content, because all it's doing is overlaying on top of the phone. Whereas really, he should have kind of been able to reach in and, you know, move one of the Beatles on the road, or change their position, or something like that. But the nice thing about marker-based augmented reality is that it's very, very robust. So once it's got the image, the marker image, the actual AR experience is really, really good, because it doesn't rely on other sensors, and it can really tie itself strongly to that particular marker. But as I've shown, it still does have occlusion problems, and also the marker always needs to be in view in order for your experience to carry on. So if the marker goes out of view, then the augmented reality experience finishes. So it's kind of limited, especially in landscapes. So to come back a little bit to that original question, how can we use this stuff to reconcile the kind of lab-based computer approach to the landscape with the field-based phenomenological approach? I want to go through an example, a case study from my PhD, where I've tried to use this mixed reality approach within a proper landscape to create something which I've called the Embodied GIS. So, the case study I'm going to use is Lescanic Hill, which is on Bodmin Moor. It's a Bronze Age settlement, mostly Bronze Age. There are other periods there, but the main bit is Bronze Age. It's probably most famous because it was used as a kind of exemplar of the phenomenological approach in the late 90s by Chris Tilley, Barbara Bender and Sue Hamilton, they went down onto Lescanic Hill and they did some excavation, but then they also did quite a lot of phenomenology where they sat in the houses and looked through the doorways and tried to figure out what views people might have had, and then they wrapped up certain stones in the landscape with kind of yellow cling film in order to sort of bring certain elements of the landscape out and everything. So I wanted to kind of revisit this strongly phenomenological case study and then try and bring a bit of computer analysis to it, but also to respect their original approach as well. So the settlement is made up of about 50 roundhouses in the middle there, as you can see, they're in red. And then all of the green diamonds, they are all ritual monuments or cairns, that type of thing. And then all of the little hammers, little black squares, they are tin mining areas. So there's lots of kind of resources going on around there, but there's lots of ritual area. And then also there's lots of other houses as well. So you can see off to the west there, there's houses all up on Cat's Holds Down and a hill called Brown Willie, which is the biggest hill in Cornwall. So there's quite a bit going on here. This is what Lescanic looks like from the south. A little nubbin on the top there is a big platform cairn, and then all of those grey rocks down the side are either houses or enclosure walls and that type of thing, or cairns as well. This is what it looks like looking west from almost at the top. So that hill on the right hand side there, that's Brown Willie, that kind of rugged hill. And then as you can see, the kind of landscape is grassy heathlandy, but also very, very rocky, especially on Lescanic. Now a lot of those rocks there are actually houses, and I could tell you there's probably about 11 houses that you could see from that particular spot, but they're virtually impossible to see on the ground just from looking at it like that. This is what a roundhouse looks like generally. So yeah, as I say, there's about 50 recorded, and they're all in varying states of repair. This is quite a good example. So there's 1 or 2 courses of walls, and then various doorways and all of that type of thing as well. At the top of the hill there's this really cool thing called the propped stone, which is a culturally altered, modified stone which has been lifted up and then propped with other stones to create a small gap. This is this rock on the right hand side here at the strange angle. And so there's a little hole through there, and then on the midsummer solstice, as the sun rises through the little hole and shines all the way through. So it's very highly charged ritually, and there's lots of things going on up here. But what I really wanted to do when I was up here, because I look at the GIS map and I see all of these houses, and you come up and it's virtually impossible to see where anything is and how it all fits together. So I wanted to try and use mixed reality to sort of add the houses to the landscape, basically. This is obviously just a mock-up, but this is the kind of thing which I would be interested to do. Okay, so that is basically the kind of case study. And in order to get to the bit where I put the houses into the landscape, there's a few steps to go through. The first thing is to actually build a normal GIS model of the modern landscape as it is today. So you've already seen the map there, but then I've also got a digital elevation model there, which is just from the Ordnance Survey. It's landform panorama, 30-meter resolution. If anyone wants to talk a bit more in detail about the kind of specifics of the data and everything, I'm quite happy to. Don't really have time right now, but feel free to bring anything up in the questions afterwards. So I've got a digital elevation model, I've got the locations of the houses, I've got the locations of the ritual monuments as well in my GIS. In order to start creating the augmented reality experience, I needed to put these things into a proper sort of 3D space. And in order to do that, I have turned the digital elevation model into a proper 3D model by putting it through a program called Blender, which is an open source 3D modeling program. And then I've imported that data into a gaming engine called Unity 3D, which I'm sure probably quite a lot of people have heard of now. It's been used quite a lot by archaeologists to create gaming environments and virtual models and things like that. I think it's now completely free actually, and it allows you to deploy games or apps to, you know, the web, to iPhones, to Android phones, to Flash movies, and all that type of thing. So it's a really good way of building applications, especially when you're dealing with things like spatial data, because it's, you know, it's all set up for gaming worlds basically. So you take the GIS data and you import that into Unity 3D. Okay. The raster data, as I've said, is imported via Blender, the program Blender. Now the vector data, that is the data which is the locations of the houses or the locations of the cairns and that type of thing, I've decided to write that so it's read directly from the GIS files and then is created at runtime of the app, which means there's a direct link between my GIS data and the app. So it's not like you stop doing your GIS, you compile the app, and then you go out into the field. The app is reading automatically from the GIS server, so the data is completely live, basically. Let me just show you what I mean by that. So this is a screenshot of the 3D model, the digital elevation model in Unity. When I press the play button, it queries the GIS data, bonk, and then plops those houses in their correct geographic locations on the digital elevation model. Each one of the houses can have separate attributes if you want. In this case, I've just got, you know, the house numbers. But if you know anything about the morphology of the houses, so some houses might be different shapes, or some houses might have had different uses, you could use different 3D models per different house, and that could all be done via reading the GIS attributes. If you wanted to, you could do that at runtime. In this case, every house has got the same model, same 3D model. Okay, with me, hopefully. So after we've done that, we then upload the model to the iPad. So once you're in Unity, you can press the kind of Go button, and then that will upload the GIS to the iPad. You unplug your iPad, you take it out into the field, and then we're into the actual application. So this is a screenshot of the actual application, taken directly from the iPad. So the sky there is the real sky. The grey bit is the digital elevation model. Now, in order to get around some of the problems with the compass and GPS calibration, location errors, I've had to put in a calibration stage onto the application here. So what you do, you go out into the field, you open up the application, and then you just align the digital elevation model with the real landscape, so that the grey lines up with the real landscape, and then you can't see there in the top left there's the GPS coordinates, which are being pulled directly from the telephone or the iPad. But if you know exactly where you are, you can go in and manually edit those GPS locations. Or you can connect an external GPS antenna to your iPad and get very, very accurate GPS if you wanted to. So there's lots of different ways that you can place yourself in this landscape. But the important thing is that you've got to get the virtual landscape aligned with the real landscape. And then once you've done that, you can turn off the virtual landscape, and it should then overlay the archaeological elements in the correct place on the landscape. So this is a screenshot from the application in action, where I've aligned the virtual landscape, turned it off, and it's left the houses taken from the GIS locations and put them in the correct place in the landscape. You'll have to excuse the little bottom right of this. I was using my waterproof cover on my iPad, and unfortunately it was covering up the screen slightly. So there's a few more examples here. This is me standing by one of the houses looking at some horses, and then on the right hand side there you can see some more houses excuse me, on the settlement going away behind the hill. But what the canny ones of you will notice is that some of those houses are being directly occluded by the landscape. So as they disappear behind the real world, behind the real hill, their 3D models are being occluded, and it makes it look like they're being occluded by the real landscape, but really they're being occluded by the virtual landscape, which is aligned exactly with the real landscape, if that makes sense. But essentially what it means is that as I walk, if I started walking towards those hills, towards those houses in the distance there on the right hand side, as I walk towards them, more of the houses would be revealed as I go further up and over the slope. And then you can also sit inside the houses. So as I said, a very important part of the Leskinik work was recording views from doorways, and this particular house that we're in at the moment, which is house number 3, was a very important house called the Shaman's House, because it had a very specific view. So that little nub on the top of the hill, straight in the middle of the doorway, that's actually the top of another hill called Rao Tor, which is theoretically one of the most ritually charged hills on Bodmin Moor. And so this house was specifically placed, apparently, with the doorway completely aligned to that little nub of Rao Tor as it comes over the top of those hills. So what was very nice when I went up there was to be able to recreate that view, sit in house number 3, put the house on, and then look through the doorway and see this very highly ritually charged view. And so effectively to rerun some of the experiments that Chris Tilley et al. Did, but using the embodied interface, embodied GIS interface. So it's not all just doing it from, it's not all just doing it from within the settlement. So here I am standing on the top of Brown Willie, the highest hill. On the left hand side is the non-augmented view of Leskinik Hill from Brown Willie, so you basically can't see the hill at all. And then on the right hand side is the screenshot from the Embodied GIS application, and there you really can see the settlement, and you can see what a difference it makes to that view, how your view is kind of drawn towards the settlement, and how it really starts taking a part of the landscape. And then, of course, if I started walking towards that settlement, the houses would get bigger as I got closer, and then you would actually be able to experience what it was like to approach Leskinik from, a specific place. So you're really kind of, it's very possible to use this interface to kind of have an embodied experience of the Bronze Age landscape. And obviously we're doing that from a modern perspective, but it, it opens up different avenues, and it kind of allows you to experience something in a way that you simply can't. If you can't see the settlement when you're walking around as a phenomenologist, and B, if you're just looking at a computer screen and you just see red dots. So what I'm trying to do here is really combine these two quite powerful approaches to landscape analysis, and then just sort of bring them together using this particular interface, so you can experience them both together and then get the strengths of both of them at the same time. Okay, so the embodied GIS then, basically we've got live GIS data being placed in real geographic space live, right? Using the virtual model of the landscape allows for this sort of realistic occlusion of the virtual objects when they're viewed through the AR view. So if we go back to that Brown Willie example, if I'm walking down from Brown Willie, I walk to the bottom of Brown Willie, and then the settlement will be hidden by the little hill in front of Brown Willie, and then as I come back up the hill from Brown Willie, the settlement will start to appear again, and it will go in and out of view depending on what the real landscape is doing. And so by using the virtual model of the landscape, I can recreate those kind of, the settlement going in and out of view in the augmented view as well. So it makes for a very kind of visceral experience. Something else which is really important here is to think of this AR application as just another way of looking at the GIS data. So I didn't want it to be a separate thing that you just go off and do. I wanted it to actually be able to feed back into the GIS as well. So this little screenshot here is a viewshed that I calculated from a particular place on Lescanic Hill. I went out with my Embodied GIS application, I overlaid that viewshed on the landscape in the real place. So everything in red is what the computer thinks I should be able to see when I ran my viewshed. Okay? Then those little yellow pieces in the viewshed, the computer doesn't think that I should be able to see them if I'm standing in that particular location. Whereas when I actually take these results out into the landscape, I can see those little yellow pieces, which suggests that my viewshed algorithm is slightly wrong. So I could, in this case, go and ground truth the viewsheds by going out there and say, oh, actually, computer, you're a little bit wrong here. You know, I can actually see these little edges of this ridge, and so I can kind of highlight them within the AR application and feed that ground truthing information back into the GIS data. So it's a real kind of